and then handed back out to the discriminator. Since then, yeah, I think I just eventually turned this into a convolutional neural network. But like I said, this isn't the model that I spent the most of my time on just because I didn't have a whole lot of success early on. But just for sake of time, we'll close this and just go to the meat of the presentation. Same with the WGAN, same with the convolutional neural network. Didn't get a whole lot of value out of those. So here's where I spent, like I said, the majority of my time. I just put it in a function just for like ease of mind as far as bouncing between models. And basically this model is a similar situation as before, although I start to mess around with the output channels as far as just like how much do I want to scale them. And so this has changed quite a bit as far as how much how much depth do I want to add to the model as I go through my encoder, and then how much do I want to just keep it the same. So this is a little bit different, again, just based on that, and we have a stride of 2, so it's reducing the size of the model each time. And then this gets flattened down to just a single latent dimension, if you will. And then here, the decoder is basically just a convolutional transpose function that runs on the model and just undoes all of the work that the encoder does. Let's see. So again, this is what I was mentioning earlier. When it's in lab and we're in lab space, throw a sigmoid layer at the end of it. When we're in RGB space, throw tanh. Have I been doing this wrong? I don't think so. Lab sequential decoder and lab. Huh, yeah, I think these should actually be flipped. That's fine. So we can just do or when not lab. I would love for that to be the prop, but I highly doubt it is. So yeah, that's where I got a lot of the traction, and then basically just bring those two together, encoder decoder and model. So let's close this down for simplicity's sake, and then I'll actually run this again after this presentation just to see if that really was the cause of my errors. So for this linear encode model, basically I just replaced I think I flattened at the very beginning. Here, let me just take a look at it. Let's see. Yeah, flatten at the very beginning, try to run a single linear layer on it, and then linear layer, because I don't have to unflatten, and then view it back as a 3D object. So this is like a really, really bare bones model, and for whatever reason, this just had way too many parameters going on. It would crash before it even got through the first epoch, so like it used all of the RAM on that. So didn't get to spend too much time, but that was a bit of the difficulty there. So this is the train model that I used for a while. I don't think it's too important, especially because it didn't work quite as well. But I tried to take the GAN model trainer that we did and just kind of strip away all of the excess that we didn't need. But clearly not as robust as like the train network that we used. So this is what I used for a while, especially when I was training the GAN. But I think eventually I got around to figuring out the best way to represent the model. Let's see. Yeah, so this is getting set up for the training section of the model. So mean squared error loss. Here's that get autoencode model that I was, or get autoencode model function that we just looked at with a leak rate for the leaky ReLUs, and then whether or not we're in lab space. Like I said, we'll run this again just to see if we get better results. Optimizer, just using Atom. Didn't really get a huge difference between Atom and SGD, stochastic gradient descent. So right now just using Atom, but definitely something I can play around with if I find where some of the other errors may be. And then I was using a cosine annealing learning rate just to kind of make sure I was using all the tricks I had at my disposal, just something to see if it was getting too close to one wrong solution, and just giving it something to spice up the learning, if you will. So here's just a little helper function, plot results, that prints out the train loss and val loss of the model. And that's because I made this pretty handy wraparound function. I guess not wraparound function, but wraparound logic that basically lets me denote how many rounds I want to run, how many epochs per round, and it will save the results and add it to a data frame as it goes through. So this was pretty handy as far as when I got to a point of training the models, where this will, right now, if we're at 10 epoch or 10 rounds, 1 epoch per round, this image will reset every epoch. And if I prematurely exit out, keyboard interrupt, I'll have whatever my last saved results were still, which is nice, and I'll have a visual of what was going on. So this is just a nice clean way that let me train the model for variable amounts of times. I could say, hey, like I want to train for 200 epochs, but if I show up at 50, like I don't want to have all that time be for naught. So that's what was going on there. That was pretty helpful, although I wish I came up with that earlier. And then this is my model for generating the images. So pretty similar. I think this is more or less taken from the auto encode, trying to come up with from numbers chapter. I think it was like chapter 7. Grabs the black and white images from the train loader, puts them on the right device. Oh, let's reconnect. Puts them on the right device, reshapes them accordingly, and then generates some fake images. And then this is why earlier I had chosen my batch number to be 1, and it was just, like I said, for simplicity's sake, just something I didn't really want to use the bandwidth to figure out if wasn't getting the results to begin with. So that lets me just generate a single image because the bandwidth, or because the batch size was 1, and I don't think I did any other hard coding up top. So it gives me the fake image, that's the generated one, so encode decode BW, the black and white one, that's the reference image, and then the color image. And then again, we just had to bring them all back to the CPUs so that we can actually view them. So here were some of the results. And like, as we can see, reference predicted this was what the target was. So it does a pretty good job of at least giving the general shapes back. Kind of hard to see here. Might be able to pull one from the slide deck. But this model just does progressively worse as the values, or as like the epochs, as it trains for like more and more epochs. So the very first few ones, it does like a really good job of basically just being an identity matrix that condenses the information down to like whatever the dimensions were for that latent variable, and then back up to like a 26 by 26 3-channel image. But here we start to get this amber tint to it, and it starts to like really blur out some of the details. So it still has the good overall shape, but like really starts to lose like some of the detail work in the image. And then here, I think CAE is just basically this like repeated. And then here for the CNN, I had run like I said, just a basic CNN just to get an idea of what's going on. And then just wild off the mark results. Again, it could be just that I had flip-flopped, that I thought I was in lab space when I was in RGB space. I kind of doubted at this point. I think this is like at a time where I was still just using RGB. No, I think I was using lab space because I was using hyperbolic tan. But we can take there. So yeah, like I said, really, really basic input, bunch of just hidden layers that do basic convolutions on them, and then output, same dimension all the way through. Again, got cosine annealing, going on. So we can see that it's like adjusting the learning rate, and we can see that in the accuracy over time. And yeah, like I said, I was using lab space at the time of like these predictions. I guess these are the same. Over here's different as well. But yeah, these really missed the mark as far as like condensing the image down to a single row. Wasn't really sure what was going on with that. May have been a permutation issue that I just never sorted out, but that was a really bizarre thing. Especially, I wonder if I can zoom in, maybe. No, especially because after like really staring at it, like you can start to make out that there are relevant features in it. So this looks like glasses, nose, top of the mustache, and matches kind of up with what the target was. So I'm not sure if it's just the images, like I said, just in like the wrong permutation, like the wrong order, and so it's printing out just really, really small squares. But I think that was just maybe a possible solution that I didn't think of at the time of running the model. But yeah, this is, I think, pretty much the best results that I have so far. Let's see if, again, let's go to CNN auto encode. So yeah, we can see some crisper ones over here. And I think I was training like 80 epochs, maybe, yeah, 20 epochs. So like I said, it starts to do worse over time, but some crisper results as far as taking this information, condensing it down, blowing it back up. And it really just throws like an amber tint over the original image. And I'm not sure why, but I'm also getting these kind of grid marks that overlay the image. So I wasn't really sure what was going on or how to smooth that out. But that's something that I noticed. Again, it's looking back. Yeah, I think this was like no, those are CNNs. Like even like this one, it like cuts at like a very clean third. So I'm not really sure what's going on there. But like I said, this is more or less like the best that the model did as far as just gridding out the image, handing back a slightly ambered version of it, and still trying to figure out what's the reason for that. Again, I'm going to run this document again just to make sure that I'll pull it back up just so you see. Yeah, I'm assuming that I must have yeah, maybe I'll do this as a better way of not having to redo the comments around it. Yeah, because I'm predicting the lab space output should be between -1 and 1. That's hyperbolic tan. 0 to 1, that's signaling. See, I'll run this again. Maybe I'll run in 20 to 100 epochs, and just to get an idea of what's going on. But more or less, that is my project. Thank you, and thank you very much for this semester. This has been quite the head scratcher of a project, although like as you can see, I put a lot of time and effort and learned a lot despite the results. But thank you very much. Merry Christmas. Hopefully I'll see you around.